Hello and welcome to Chapter 13. Today we're going to look at Section 13.1, which deals with right triangle trigonometry. From geometry, if you recall, the three sides to a right triangle include the hypotenuse, and the hypotenuse is the longest side of your right triangle, and it's also the side that is opposite of your right angle. We also have, and let's call this right here, A is really going to equal this O looking letter is what we call theta, and it's a variable just like X or Y or Z would be, but theta represents an angle. So the side opposite of theta is going to be this side right here. The side adjacent, and adjacent, if you recall, means next to. So this right here would be the adjacent side to this angle theta. Now the ratios of these three sides are used to actually define the six trig functions of sine, cosine, tangent, cosecant, secant, and cotangent. And this table can also be found on page 769 of your textbook. But for now, the sine, and if you notice, we have shortened sine, cosine, tangent to just the first three letters. And then when we get over to cosecant, it's CSC, secant is SEC, and cotangent is COT. These are the abbreviations. Now the sine of theta is equal to the opposite side. And again, this here is theta. So sine is the side opposite over the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. And tangent is equal to the opposite divided by the adjacent side. Now you may have heard back in geometry that we have SO, CA, and TOA. You can also use these to help remember the sine, cosine, and tangent values as well. Okay, now for this problem here, you're going to have to remember the Pythagorean theorem. And if you recall, the Pythagorean theorem for a right triangle says a squared plus b squared equals c squared, with c squared being your hypotenuse. So I need to find the length of my hypotenuse, and I'm going to do that by taking the square root of the two side lengths, which is 5 squared plus 12 squared. This is going to give me the square root of 25 plus 144, which is equal to the square root of 169, or 13. So now, over on this side, or to your left, I'm going to identify the three things I need to know in order to find my six trig functions. So I have my adjacent side, my opposite side, and my hypotenuse, which we just solved for hypotenuse as 13. Now, the side adjacent to or next to my angle is equal to 5, and the side opposite is 12. So now that I have these three sides, I can go ahead and find my six trig functions, and we'll start with sine theta. Sine is equal to the opposite, or 12, divided by your hypotenuse, which is 13. Cosine theta is equal to your adjacent, or 5, divided by your hypotenuse, which is 13. And tan theta is equal to your opposite, which is 12, divided by adjacent, which is 5. Now for secant, cosecant, and cotangent, I'm going to pair them up with the appropriate sine, cosine, and tangent values. The reciprocal of sine is actually cosecant theta. So if sine theta is equal to 12/13, then I know cosecant must equal 13/12, because that's the reciprocal of 12/13. Secant theta is then the reciprocal of cosine theta, and cosine theta was 5/13, so secant theta must equal 13/5, and cotangent theta is the reciprocal of tan theta, and tan theta was 12/5, so cotangent must be 5/12. Now, with trig, the angles of 30 degrees, 45 degrees, and 60 degrees occur quite often within trig itself. So, you have a table given to you. You could also find a similar table in your textbook. And these are values that you will end up knowing by the end of the year. So I would suggest that you kind of start brushing up on them. Again, your 30, 45, and 60 degree angles are the most common. However, we will be looking at 0 and 90 degrees as well this year. To see where these values come from, sometimes it is nice to draw a right triangle. If I draw an isosceles triangle so that I have two 45-degree angles, each side length has to equal 1, and then the hypotenuse would be 1 squared plus 1 squared, and take the square root of that, or a square root of 2, and that's where I get my 45-degree pieces of information right here. I'm going to, if I wanted the, let's say the sine of 45 degrees, which is right here, I'm going to take the opposite over the hypotenuse, which is 1 divided by the square root of 2. So 1 divided by the square root of 2. And if you rationalize this, this gives you the square root of 2 over 2, which is actually what you can find right here in the table. Okay, so that's how that works. Now the same thing for your 30, 60, 90 triangle. The side ratios go 1, 2, square root 3. So if you wanted to take the sine of 60 degrees, the sine is equal to the opposite divided by your hypotenuse, or the square root of 3 over 2. And if you need more help with this, let me know and I can help you with this in class. Now we need to know these lengths because sometimes trig functions can be used to help find missing lengths or angles in a standard right triangle. This is called solving a right triangle. And let's look at example 2 so we can see how this works. Example 2 says to find the value of x for the right triangle shown. Well, when I look at this triangle, I see that I'm given my angle of 30 degrees. I have a side that is adjacent to, and I have a side that's the hypotenuse because it's the longest side and the side that's opposite of the right angle. So because I'm given an adjacent side and a hypotenuse, I know I'm going to have to use the function cosine because cosine is the only function that deals with both the adjacent and the hypotenuse side. So I can take the cosine of my angle, which is 30 degrees, and set that equal to my adjacent side, which was x, and divide that by 8. Now, 30 degrees is one of my standard angles in trig, and from the previous table, which I'll later on get to know, I know that cosine of 30 is also equal to the square root of 3 over 2. So by looking at this, I have two equations set equal to one another, and I have one variable, so all I have to do now is cross multiply and I can solve. So if I go 2x equals 8 square roots of 3, divide everything by 2, then I get x is equal to 4 times the square root of 3. And before you type this in your calculator, you must go to the mode setting and make sure you are in degrees because we're given degrees right here. If you are not in degree mode, you will get a different answer. So 4 square roots of 3 is actually equal to approximately 6.93 degrees. Example 3 says to solve triangle ABC. Well, I'm given 28 degrees right here. I'm given 90 degrees. So when we're solving a right triangle, we are looking for all side lengths and all angles. So I know that A is equal to 28 degrees, C is equal to 90 degrees. Now I can go and find angle B by taking 180 degrees and subtracting my 90-degree angle and my 28-degree angle. And this will give me 62 degrees. So now I now have angle B, and we'll just write that in here as 62 degrees. And now all I have to do is find side lengths A and C. If I look at A right here, so put a circle around A, let's look and see what I have. I'm given that I have an angle of 28 degrees, and with that 28 degrees, A is opposite of that, and I'm given an adjacent side. So because I have an opposite and an adjacent value to this angle right here, I know that I can use tangent. So the tangent of 28 degrees is equal to the opposite side A divided by the adjacent side, which is B, or 15. Now to solve for A is going to equal 15 times the tangent of 28 degrees, which is, so 15 times the tangent of 28 degrees is equal to 7.98. So I now know that side A is equal to 7.98 units. Again, you have to be in degree mode for this to work. Now the only other side length that I need is side length C. So for side length C, I see that I'm given angle 28, and in reference to angle 28 degrees, C is considered the hypotenuse, but I'm also given side length B, which is adjacent. So again, I have an adjacent and a hypotenuse. So for side length C, I can use my cosine of 28 degrees is equal to adjacent, which is 15, divided by my hypotenuse, which is C. Now I need to get C by itself, so I'll multiply both sides by C, and I have C times the cosine of 28 degrees is equal to 15. To get C by itself, and let's change colors here, I'm going to take and divide 15 by the cosine of 28 degrees, and when we do that, we get 16.99, or you can round up to 17 if you choose to. So angle B is 62 degrees, which we found up here. Side length A is 7.98, or you could round to 8, and side length C is 17. Now, for your fun fact, and this fun fact comes from kidsmathgamesonline.com. It says, triangle shapes are often used in construction because of their great strength. Now, this is actually a very true statement because when I was an engineer, anytime that we needed something that would be structurally sturdy or stable, we would use a triangular shape in the design of our project because it was the strongest geometric shape that we could use. So, with that said, have a good night, and I will see you in class. Thanks.